Okay, today we're going to be taking a look at what does it mean again. So here's a bunch more examples, and we're trying to figure out what is the meaning of g prime of 2 equals negative 5. So for our homework, we're going to have to first find g prime of 2, and they will give you the g function, so you just do the derivative, and then you want to evaluate it when x is 2. So then what would be the meaning of this, and how would we get these units here? So first, let's figure out the units. G has units of tons per hour, and we're doing the derivative, so we're doing d dt of something that has units of tons per hour. So you can see that we have units of hours here, and these are also units of hours, so that's why we're getting hours squared. So it's going to be tons per hour squared. So every time you do the derivative, you're going to get an extra unit of time on the bottom. So this is important. This is going to help us understand what's going on sometimes. So now let's pay attention to what is the meaning of g prime equaling a negative number. So when the derivative of g is negative, it means that g is decreasing. So that's how I'm going to start off. I'm going to say g is decreasing at this rate. So here's our rate right here. It's 5 tons per hour squared. And this is all happening when t is 2, and the units are still hours, so it's going to be when t is 2 hours. And then before I move on, I do need to describe what g is. So I'm going to replace g with the rate that gravel arrives. So let's do that. Let's trade g of t for the rate that gravel arrives. Okay, there we go. You can see that we traded the g of t for the words the rate that gravel arrives. So now we're basically done. Our final answer says at time t equals 2 hours, the rate that gravel arrives is decreasing at a rate of 5 tons per hour. And that's it. Let's go take a look at the next question. Okay, for this one, we have a water tank, and this is the rate that we're pumping water in, and this is the rate that we're pumping water out. The units are gallons per hour. First, they're going to ask us to find this, and then we're going to have to explain the meaning of it. So if you plug this in your calculator, you're going to get 100. The reason I know that the units are gallons is because we're doing the integral of something that has units of gallons per hour. So again, these two things here have units of gallons per hour. And then there's a dt sitting right next to it. dt is time, and the time is going to match. It's also going to be hours. So that's the reason that one of the units of hour is going to cancel. And your final units will just be gallons. So that's important. We always need to know the units. But the units also helps us. It tells us what's going on here. There's 100 gallons. And because this is the rate in and also the rate out, then that means that during that time interval from 0 to 2, the amount of water in the tank has increased by 100 gallons. Again, this here is kind of like a prime. So the integral of a prime is going to pretty much just be a. So this is basically the amount of water in the tank, but we're not including the starting amount. We're just including the changes here. So that's why we're not going to say, well, this is the amount of water in the tank. We're just saying that the amount of water in the tank has increased by this amount. We're not saying that this is how much water is in the tank. Now the next question is almost the exact same question, but we're going to include the starting amount. Let's take a look at that one. So here we go. This is the exact same thing, but now we're including the starting amount. So we have the starting amount plus all the changes. So now we can say, well, this is how much water is in the tank because we're including the starting amount plus all the changes. So this is actually the exact amount of water in the tank at this moment in time when t is equal to 2 hours. You'll notice I included the word hours here because it wasn't a 0. If it's a 0, you really don't have to put the units next to it. All right, let's take a look at number 4. Again, we have to first find h of 2. So they're going to give you the h function. You can plug in a 2 and you're going to get 5. We have to figure out what the units are. This is the h function, and those units were already given. It's just gallons per hour, so we just copy that down. It's just gallons per hour. We don't have to figure it out because they told us exactly what the units were. Now, h is just the rate that the oil is pumped in to the tank. So it does not include the fact that oil is also being pumped out. So this will not tell us how the amount is changing. All this tells us is how the amount being pumped in is changing. So all we can say is that at this time, when t is equal to 2 hours, the amount of oil that's being pumped into the tank is increasing at this rate. So it's just the amount being pumped in that's increasing. We're not saying that the amount of oil in the tank is increasing, just the amount being pumped in. So you must say this, being pumped in. This is the important part here. So this one's kind of tough. When you have two rates, you have a rate that's going in, you have a rate that's going out, and this is just the rate that the oil is being pumped in. So you got to be very careful on this one. I also want to point out that we're spelling out gallons per hour. We're not using a fraction here. So we're not going to write it like this when it's in a sentence. All right, let's take a look at number 5. This one is a similar example. Instead of water being pumped in, they just use the words entering and they use the word leaves instead of being pumped in and pumped out. But it's almost the same thing. Again, F is just the rate that water enters. So it's almost the exact same question we just did. It's just a different story. So we're going to do the exact same thing. At this moment in time, when t is equal to 3 hours, the amount of water entering the tank is increasing at this rate. And again, we spell it out gallons per hour. We don't use the fraction. So number 5 was almost exactly the same as number 4, just a little bit different story. Let's take a look at number 6. Okay, for number 6, A would be the amount of calories burned. So there's somebody on an exercise machine, and A would be the amount of calories burned. They don't give you that function. They give you F, which is the rate that calories are burned. But it's just one all-inclusive rate. So we're just dealing with one rate here, so this is nice. This is kind of like A prime. So if we do the integral of A prime, we just get A. So this is just the amount of calories burned. Now, if you plug this in your calculator, you get 300. But how do we know it's calories? Well, if you look at the F function, it's calories per minute. So we're doing the integral of something that has units of calories per minute. And then the dt is a time, so it's going to have the same units of time. It's going to be minutes. So what's happening here is we're canceling one unit of time from the top and the bottom. So our final units are just going to be calories. So that's how I know it's 300 calories. And if something is equal to 300 calories, that's basically just going to be the amount of calories burned. That's pretty easy. And it would be during this time interval. So I'm going to say during the first 3 minutes, a person that's using an exercise machine has burned 300 calories. That would be the meaning of that. All right, let's look at number 7. In this situation, A would just be the amount of cars turning left, and L would be the rate that cars are turning left. The units would be cars per hour for the L function. And they want us to find L prime of 5. So we use our calculator to find that for us, and we would get -9. And we know that L prime talks about L. So we're going to start off just by using an L. So we're going to say L is decreasing because our derivative was negative. So L is decreasing at this rate. And because we said the word decreasing, our rate is just going to be +9 cars per hour. Now we need to trade L for the meaning of L. So what does L mean? We need to plug that in. Well, L is the rate that cars are turning left. So we're going to trade L for those words, the rate that cars are turning left. Let's go ahead and do that. Okay, there we go. That's the exact same sentence. I just traded L of t for these words here, the rate that cars are turning left. And now I'm done. My final answer says at time t equals 5 hours, the rate that cars are turning left is decreasing at a rate of 9 cars per hour. And that's it. That's the meaning. Again, how did I get units of cars per hour squared? Well, L of t has units of cars per hour, and I'm doing the derivative of that. So I'm doing d dt. So dt has units of time, which is also the same time as this. It's hours. So it's kind of like we have 2 hours on the bottom being multiplied together. So we end up with cars per hour squared. So that's one way you could think about it. And that's the reason why we have hours squared on the bottom. Another way to think about it is that every time you do the derivative, you're going to get one more unit of time on the bottom. So instead of just hours, you're going to have hours squared. All right, let's go ahead and take a look at our last one, number 8. Okay, for number 8, we have R of t, which is the rate that people get in line. And then we have 800, which is the rate that people get out of line. Because we're including the starting amount of 700 plus all the changes, then the meaning of this is just the amount of people that are in line at the ending time. So the ending time is when t is 4. So we would just say, well, when t is 4 hours, there are 1,700 people in line. Again, this part right here is the total change theorem. You should recognize that. Whenever you have the starting amount plus all the changes. And this doesn't have to be a 0. This can be any time as long as it's the time when you have this amount. So if you have the word problem, you would see that when t is 0, you're starting with 700 people in line. And so this is the changes from 0 to 4. So this is the ending time when t is 4. So that's why this is the amount that we have at that moment when t is 4 hours. This is both of the rates, the rate in minus the rate out. So that's pretty much it. That was 8 more examples of explain the meaning of this. And this is one of the most important parts of understanding these kind of questions. If you can explain the meaning of these integrals and these derivatives, then it helps you with everything else you do on these free response questions. All right, that's it for today. Now it's just time to practice.